When I say the word evolution, what's the first thing that pops into your head? For most of us, it's probably, a massive timeline that stretches back millions and millions of years. We're thinking ancient fish, dinosaurs, early humans, that whole epic story. It's really easy to frame it as something from the deep, deep past. But what if I told you that story is still being written? I mean, right now, all around us.
Which leads us to this big question. We all get the fossil record and those huge long-term changes, but is that engine of change, evolution itself, actually still running today? Is it something we can literally see happening with our own eyes?
The answer is a huge, resounding yes. Seriously. This isn't just some dusty theory about what happened eons ago. It's an active, observable process. And it's happening in countless species, often at speeds that are, frankly, just mind-blowing.
So how do we know this for sure? Well, we've got a ton of evidence. For starters, with modern tech, scientists can literally detect genomic changes in real time. We can also see these subtle, continuous shifts in the more recent fossil record. But maybe the most dramatic proof? The lightning-fast evolution of resistance in things like bacteria and insects.
Okay, so let's be super clear here. We're not talking about animals suddenly sprouting wings overnight. The kind of evolution we can see happening right now is what scientists call microevolution. Basically, it's a change in how common certain gene versions, or alleles, are in a population. Think of it like the genes for eye color. If, over a few generations, brown eyes suddenly become way more common in a town than blue eyes, that's microevolution in action. It's evolution on its smallest, most immediate scale.
And that just begs the question, right? If we're used to thinking about evolution in terms of geologic time, how on earth can these changes happen so fast? Well, the answer lies in the one fundamental mechanism that's been driving life's incredible diversity from the very beginning.
And that beautiful, powerful mechanism is natural selection. This is the engine. It's the core process. And it's actually pretty simple. Organisms that have traits better suited for their environment are just more likely to survive, have kids, and pass those winning traits along.
Darwin broke this down into a really logical four-step process. First, you've got overproduction. Way more babies are born than can ever hope to survive. Then, within that group, there's genetic variation. Everybody's a little bit different, right? Because resources are tight, that variation leads to competition for survival. And all of that sets the stage for the final, crucial step. Not everyone gets to reproduce equally. The individuals whose unique variations give them even a tiny edge are the ones who are more likely to live long enough to pass on their genes. Simple, elegant, and incredibly powerful.
All right, so let's take this out of the textbook and into the real world with something that absolutely affects all of us. Maybe the most urgent, in-your-face example of evolution happening today is the rise of antibiotic-resistant bacteria. You've probably heard them called superbugs. And this isn't some sci-fi threat. It's a global health crisis that's happening right now.
And this right here, this visual, perfectly illustrates the whole process. This isn't just some abstract diagram. It's a play-by-play of an evolutionary war being waged inside hospitals and even our own bodies every single day.
Let's walk through it. So you have a huge population of bacteria. Because of random genetic variation, step 2 of Darwin's plan, a few of them just happen to be naturally resistant to an antibiotic. Now, you take that antibiotic. What you've just done is introduce a massive environmental pressure. It wipes out all the vulnerable bacteria, but it leaves those few tough ones behind. And what happens next? Well, with all their competition suddenly gone, the resistant survivors have the perfect conditions to multiply like crazy, creating a whole new population that the drug can't touch.
I really want to pause on this for a second. This moment is pure, raw, natural selection. In our effort to kill an infection, we accidentally create the ideal 5-star resort for the toughest bacteria to thrive. We literally become the agents of selection, personally driving the evolution of the very thing we're trying to destroy. That's wild when you think about it.
And this isn't just about bacteria. We are locked in a constant, unseen arms race with all kinds of pathogens. Viruses, fungi, parasites, they all reproduce incredibly quickly and have massive populations. The perfect recipe for rapid-fire evolution. And this process, this constant pathogen evolution, is exactly where new diseases come from. The source material points directly to the 2019 coronavirus as a perfect example of this. Viruses are always mutating, always evolving, always looking for new ways to jump between species or dodge our immune systems. This isn't some rare event. It's evolution playing out on a global stage.
Which really leaves us with this one critical question. We're developing new drugs, new vaccines, new technologies at a dizzying pace.
But the pathogens we're fighting are evolving every single second of every single day. So in this high-stakes evolutionary arms race between human ingenuity and natural selection, who's actually winning?